Mr. Hayes, we're here to go over the Chapter 10 practice test where we're going to look at the multiple choice problems only. And I'm going to go about it the same way as I did before, which is trying to figure out ways to eliminate choices, ways to find the tricks, really multiple choice strategies. So you're going to need your formula sheet because maybe that will help you out with some of the strategies, and you're going to need your calculator to help you out as well. But overall, pay attention to why I can eliminate choices. Pay attention to how I start a problem or what do I look for in a problem. Because again, it's not always about finding the right answer first. Many times you start the problem by figuring out which ones are not the answer. And so without further ado, let's begin. So question 1 is asking us a study of road rage asked separate random samples of 596 men and 523 women about their behavior while driving. Based on their answers, that each was assigned a road rage score from 0 to 20. Are the conditions for performing a two-sample t-test satisfied? So I'm going to read through my choices and figure out which one it is, maybe even eliminate some as I read through. So A says maybe. We have independent random samples, but we need to check for normality. And so A sounds pretty good so far. I mean, statistically it has the right phrasing. Let's look at B. No, road rage scores in a range between 0 and 20 can't be normal. I think they can. I mean, that one I'm still like, I put a question mark like, huh? Why are they even asking that or saying that one? Think about it. You have extreme road ragers, and you don't have too many of those. You have extreme slow drivers who have, they're calm and peaceful and they're going 25 miles under the speed limit. And then you have most normal people. So I think it could follow an approximate normal shape. So I just put a question mark there. That one, I don't see any statistical relationship there. So I might throw out B. I'm not sure yet. C, no, we don't know the population standard deviation. Well, isn't that when we use T procedures? If I say we're going to do a T test like this one does, and we use them when we don't know the population standard deviation. So I can cross out C because if I don't know the population standard deviation, I'm going to proceed with T procedures if conditions are met. Yes, the large sample sizes guarantee that the correct corresponding population will have an approximately normal shape. Okay. Yes, we have two independent random samples and large sample sizes. Well, I'm throwing out B now. I'm not going to deal with B. A, D, and E all sound familiar and sound like really similar. You can see me, I've underlined a lot of them. Independent, random samples, check normality, large sample sizes, will be normal, independent, random samples, large sample sizes. Those words all sound the same, like they're repeating. So they all have things in common, which means I better know my concepts. And that's what I'm going to look at next is what are the concepts here? So I have to figure out what are my conditions for proceeding with T procedures. Random. They both need to be random. Normality. Well, here we're looking at T, and so my sample sizes, if they're greater than or equal to 30, I can use the central limit theorem to proceed with my T test. And I do have greater than or equal to 30, so that's good news. Independent. Well, you have men and women. Independent between. That's good. Are they independent within? Which means the 10% condition in this case. And yeah, I think there's more than 5,960 men and more than 5,230 women. So I think all of these conditions are met. So I don't think it's maybe. I think we are good to go. I think, yeah, we have two independent random samples. So yes, they're independent. Yes, they're random. And there's large sample sizes, which is really normality. So that choice E, that really represents all three conditions being checked. So the answer number 1, E. All right, number 2. That's a lot of words. That's only 5 choices. Let's look at the choices. Notice in the choices, they all have a 0.03 and they all have the structure of a confidence interval. Now, if I look at that last part, it does say a 95% confidence interval. So by the way, I can do that. They all have the 0.03. So you know what? I'm not even going to bother to look at the 0.03. I have a 1.96 and a 1.645. So maybe I'm thinking those are critical values. So I'm going in this, man, what's the critical value? Well, I guess I'll read the prompt because I always want to make sure I'm doing it right and not falling for a trick. So 35 people from a random sample of 125 workers from Company A admitted to using sick leave when they really weren't ill. 17 employees from Company B in a random sample of 68 workers admitted to using sick leave when they weren't really ill. A 95% confidence interval for the difference in proportions of workers at the two companies who would admit to using sick leave when they really weren't ill is. So yeah, it is. It's a confidence interval. It had the structure of my choices, so I saw that first. So sometimes I can look at the answers first, especially when they all look very similar. I can look at what's the difference. And by the way, the first thing I see is the critical value. Well, the confidence interval tells us the critical value. Well, if I have a 95% confidence interval, that's really like, it's approximately 2 with the empirical rule. I mean, 1.96. I would really have that one memorized. Which means, by the way, I can cross out A, C, and E. All gone over there. I only have B and D left. So all I'm looking at now is inside the radical. So I can go through and eliminate choices this way. And this one, by the way, be aware, there is a really hard trick here. And so we're going to go through is what's the difference so far. And I want to show you, you're going to have to find x sub 1, you're going to have to find n sub 1, you're going to have to find p hat sub 1, and the same thing for x2, n2, and p hat sub 2. Now notice, and I want to show you this. I know I have the answer there, B, but there's a reason why you need to listen to this. D is the trick. People want to choose D. And the reason why is because D uses the combined proportion. P hat sub C. It uses that combined proportion in the standard deviation. B, that one uses the p hat sub 1 times 1 minus p hat sub 1 over n1, p hat sub 2 times 1 minus p hat sub 2 over n2. It uses the sample proportions. So be aware, p hat sub C is used for significance tests. And then the p hat 1, 1 minus p hat 1, that whole thing, that's used for confidence intervals. So the answer is B, but the trick answer is D because combined here. No. Confidence intervals, you use the sample proportions. On significance tests, you're trying to get a good claim. And the claim, well, we don't know because we're looking at the differences. You're looking at the combined probability of them. So be aware, this is a really hard one on a test because they're trying to trick you with that combined proportions. So let's look at number 3. Wow. Number 2, I thought had a lot of words. Number 3 has that one beat. But I'm going to use the same strategy. I'm going to read my choices to try and help me before I start reading all those words. But I'm also going to make sure I know what I'm looking for. So when I go down here, I'm going to read that last question. Which of the following conditions for performing the appropriate significance test is definitely not satisfied? So it says both populations are normally distributed. It says the data come from 2 independent samples. Both samples were chosen randomly. The counts of successes and failures are large enough to use normal calculations, and both populations are at least 10 times the corresponding sample sizes. So those are conditions. So now, when I read this entire thing, I'm going to keep in mind, I'm looking for the conditions. And as I read one, maybe I'll highlight it, and I'll start crossing out the ones that I don't need to use anymore. So the power takeoff driveline on tractors used in agricultural equipment is potentially a serious hazard to the operators. The driveline is covered by a shield in new tractors, but for a variety of reasons, that shield is often missing in the older tractors. 2 types of shields. There's bolt-on, there's flip-up. It was believed that the bolt-on shield was a nuisance by the operators, perceived that way, and it was deliberately removed. How dare them? But the flip-up shield is easily lifted for inspection and maintenance and may be left in place. In a study initiated by the U.S. National Safety Council, random samples of older tractors with both types of shields were taken to see what proportion of shields. Well, hold on a second. I said the word random, didn't I? I said that there was random, it says random samples of older tractors and new tractors, both tractors, the shields, both were random. So what does that mean? That means I can cross out option C. Because option C says, hey, both samples were chosen at random. That was violated. No, that one was not violated. They did that, so that's good news. I can cross out C. Let's keep reading that. Of the 183 tractors designed to have bolt-on shields, 35 have been removed. Of the 136 tractors with flip-up shields, 15 were removed, etc., etc., etc. What does that mean? Well, that's my counts of successes and failures. I do have at least 10 successes and 10 failures. 35 have been removed of the 183. 15 removed of the 136. I do have at least 10 successes and 10 failures in each group. So that one is good, which means I could probably cross out D. So there we go. I can keep reading as well. Notice I have highlighted a couple things in green here as well. My green is the independent, that 10% condition. Well, in this case, Can we assume there's more than 1,830 tractors with the bolt-on shields, and there's more than 1,360 tractors with the flip-up shields? And I think that's safe to assume. And so really, no conditions were violated. So I could say, wait a minute. If no conditions were violated, why am I telling you A is the answer? None of the choices say none of the conditions are violated. That's because A is the trick. When you have your successes and failures, at least 10 successes and at least 10 failures, you can proceed with normal calculations because it's approximately normal. And that is why A is the trick. Is because your distribution is approximately normal. There is one word missing from A, approximately. And that's why A is your answer. Yes, you have 10 successes. Yes, you have 10 failures. And we said that in D. But our distribution is not normal. It's approximately normal. So it is that is right there. We were never given any information about the true population. Both populations are normally distributed. That was not given to us. So 3, one word there, right? One word just caused us to maybe fall for that trick. So be careful with your reading. Now let's look at 4. A quiz question gives random samples of n equals 10 observations from each of 2 normally distributed populations. Tom uses a table of t distribution critical values and 9 degrees of freedom to calculate the 95% confidence interval for the difference in the 2 population means. Janelle, on the other hand, uses technology, her calculator, for the 2 sample t interval and gets 16.87 degrees of freedom to compute the 95% confidence interval. Assume both Tom and Janelle did the intervals correctly. They made no mistakes. Which of the following must be true? Tom's confidence interval is wider. Janelle's confidence interval is wider. Both confidence intervals are the same. There's insufficient information to determine which confidence interval is wider. And Janelle made a mistake. Degrees of freedom has to be a whole number. Which, by the way, I'm going to cross that one out. Since Janelle used her calculator, the calculator will give you the degrees of freedom from the formula. That, we don't want you to do the formula by hand. The calculator does that formula. So degrees of freedom when you use the calculator can be a decimal. So I'm crossing out E. So I have to read through the rest. But what I really want to do is figure out, well, what's the difference? And so what I want to know is this. T distributions have more area in the tails. As the degrees of freedom increase for a T distribution, the shape of that distribution approaches normal. Now, it doesn't equal normal, it approaches. It's approximately normal. Remember that from the previous problem? It's approximately normal. Now, what that means is the higher degrees of freedom, the closer it is to a normal, approximately normal calculation. The lower the degrees of freedom, more area in the tails. So the lower degrees of freedom, the more area you're going to have in the tails. The higher the degrees of freedom, the more the area is going to be towards that center because it's approaching that normality curve. So when we're doing this, I'm going to keep that in mind. And so C, by the way, is the trick. You want to read, hey, well, they're both doing 95% confidence intervals, and that's true. But if you were to look at even the table B, where it's 9 degrees of freedom, and even look at table B and just even, let's be fair, let's round down to 16 degrees of freedom, you would probably have smaller area in the tails with that 16 degrees of freedom. So they're not going to be equal to each other. People who choose C just said, hey, well, they're both doing 95%, so they got to be equal. No, they both have different degrees of freedom, so they both have different shapes. And I'm showing you that here. Here's Tom. In this same graph, here's Janelle. Now, I can't overlap them with each other, but let me show you this. Here is the T distribution for Tom, negative 1.96, 0.041 in the tail. Okay, that's what that highlighted part is showing you. Same one over here on Janelle, negative 1.96, 0.034 in the tail. There is less area in that tail with Janelle. So in that case, I'm going to go ahead and tell you that Tom's confidence interval has to be wider because it has a larger area in the tail. So it is wider than Janelle's. So this one's really nothing to do with the whole idea of T differences, and it really has to do with T distributions and remembering the idea of the shapes of them. So let's move on to question 5. Okay, seriously, so much reading in these problems. This problem goes with both question 5 and question 6, but I'm going to do the same thing I've been doing in this video, which is I'm going to look at my answers. Because quickly looking at them, I do see a couple things. I see that A, B, C all have T equals. D and E have Z equals. So the first thing I'm going to approach this with is with the question. Am I looking for a Z or am I looking for a T? Because if I do that, I can eliminate either 2 choices or I can eliminate either 3 choices. So in other words, do we know the population standard deviation? So when I read this, I'm going to keep that question in mind first. And I already have it highlighted, but I'm going to read it. A researcher wished to compare the average amount of time spent in extracurricular activities by high school students in a suburban school district with that in a school district of a large city. The researcher obtained a simple random sample of 60 high school students in the large suburban school district and found the mean time spent in extracurricular activities per week to be about 6 hours with a standard deviation of 3 hours. The researcher also obtained an independent simple random sample of 40 high school students in a large city school district and found the mean time spent in extracurricular activities per week to be 5 hours with a standard deviation of 2 hours. Suppose the researcher decides to carry out a significance test of blah versus a 2-sided alternative. The correct test statistic is Z or T. Well, anywhere in that whole thing does it tell me the population standard deviation for the large school is, the population standard deviation for the suburban school is? No. It gives me the standard deviation from the samples, which means I am dealing with a t-test. So I can eliminate choices D and E right away. And that's how you kind of have to approach it. Now, I'm going to do the same thing I did before. What's the difference? Well, I have to keep in mind the whole idea of what's the formula. Man, have that formula sheet ready. Didn't I say that? And I'm going to look at what's the formula, what's the same, what's the different. You know what's interesting when I look at A, B, and C here? They all have the same top. They all have the 6 minus 5. So what do the choices have in common? They all have that 6 minus 5 minus 0. I don't care about that then. So really, if I look at A, B, and C now, the only difference is what's in the square root or even where the square root is, or if there isn't even one, like in C. So maybe I could quickly look at that formula sheet and find out which one is using the real one. What's different in the choices? What's different is the standard deviation formula that goes in the bottom of this test statistic. So that's where I'm going to focus. And if I look at the formula sheet, it's your sample standard deviation squared divided by your sample size that corresponds to it. Add them together, take the whole square root. So which of these looks like that one? Well, the one that looks like it that's using the right numbers, I'm thinking is B. And so B is your answer. So I didn't do any calculations. I found out what can I eliminate first. I was able to eliminate 2 choices. And then I'm like, well, what's the same on all of them? Because I don't care about what's the same. And they all have the same numerator. The only difference was the standard deviation formula, which I could look at the formula sheet and quickly look at my choices and figure out which one it is. So that is question 5. We're going to use the same prompt for question 6. I am not going to read it again. Like I said, I'm not reading that entire thing all again. I will refer to it when I need to. I'm just going to start with what question 6 is asking. It says the p-value for the test is 0.048. A correct conclusion is. So I'm going to quickly just skim my conclusions for a minute. And it says fail to reject at alpha equals 0.05. Fail to reject at alpha equals 0.05. Fail to reject at alpha equals 0.05. Reject at alpha equals 0.05. And then reject at alpha equals 0.05. So here's the good news. None of those statements say except the null in some way, which is good. If one of them said that, I would cross them out. So I guess that's not good. I kind of wish one of them did so I could cross it out and eliminate a choice. But I read through to make sure they all had H sub O. They all had the null there, because that is one thing they could do. But I also noticed when reading them, they all have the same significance level, 0.05, which is, they have that the same, so that's good news. Because that means I don't need to focus on that. What I'm going to focus on is how does my p-value, that 0.048, how does that relate to my alpha level of 0.05? Because they all have that alpha level. And in this case, 0.048 is less than 0.05. Which means we reject the null. When your p-value is less than your alpha level, you reject the null. A, B, C, goodbye, you're gone. I'm only going to choose between D and E. Those are my only choices left. If we scroll up, you can see D and E are left. So now let's go a little bit further. Reject the null at the alpha equals 0.05 level. There is not convincing evidence of a difference in blah, 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 blah. Or reject the null at the alpha equals 0.05 level. There is convincing evidence at the blah, 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 blah. I notice I'm saying blah, 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 blah because they have that all the same. The only difference is the convincing evidence or not enough convincing evidence, insufficient evidence. That's the only difference between D and E. Well, when you reject the null, you are saying you have convincing evidence to conclude the alternative. So D is saying you don't have, reject the null and you don't have it. Those are opposites of each other. So in this case, the answer is going to be E. And I did go the whole blah, blah, blah thing because if you look at it, that is the only difference here. The only difference, look at all the purple. Those are all the same words. I try to highlight them or cross them out as there is not convincing evidence or there is convincing evidence. That's really what I wanted to examine. The rest of it was just filler. It wasted time trying to read all those choices. So the answer here is going to be E. So when you reject the null, you have enough evidence to conclude the alternative. So let's move on to question 7. Here we go. Question 7, speed reading. At a baseball game, 42 of 65 randomly selected people report owning an iPod. At a rock concert occurred at the same time across town, 34 of 52 randomly selected people report owning an iPod. A researcher wants to test the claim that the proportion of iPod owners at the two venues is different. A 90% confidence interval for the difference in population proportions is negative 1.54 to 1.38. Which of the following gives the correct outcome of researchers' test of the claim? So here we go. I know I read it fast because you can read slower. I'm going to go quickly read through these, and I want to tell you, I'm going to kind of think about what's going on. And when I do that, I'm going to tell you, you can cross out D and E. Here's why you can cross out D. It says since the confidence interval includes more negatives than positives, the researcher can conclude higher proportions of people at the rock concert own iPods than at the baseball game. That's not how conclusions work when it comes to confidence intervals with the difference of proportions or even the difference of means. We're looking at is 0 captured or not. So D's conclusion doesn't even make sense with how we have been concluding our statements with confidence intervals. And E says, hey, wait a minute, the researcher cannot draw conclusions because he's doing a confidence interval. He's not doing a significance test. You have to do a significance test. And you might go, well, that makes sense because, testing a claim. But realize you can because you are doing a confidence interval which has a relationship with a two-sided significance test. And in the prompt itself, it says the researcher wants to test the claim that the proportion of iPod owners, blah, 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 is different. So is different means two-sided significance test. So I can cross out D, which means A, B, and C, those are my options. Well, what I'm going to do is I'm going to see what do the remaining choices have in common. I'm going to skim through and see what do they have in common and find out what they don't have in common. So if you look at it, everything I have in blue crossed out there is everything they have in common. So really, I can just focus on the parts that are not in common. If I try and read all those choices, it's going to all sound familiar, and I'm going to start mixing up certain words. But I can see the only thing that matters is choice A says can conclude venues is the same. Choice B can conclude venues is different. C says cannot conclude venues is different. And so those are the only things that are different. So I'm going to focus on those. So if I focus on those, that's where I'm going to be. But now, here's what's interesting. Choice A is a trick. That's really accepting the null hypothesis. You can conclude it is the same. That's really saying I accept the null. The two are equal to each other. Doesn't happen. You can never, 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 never accept the null. So that means I can cross that one out. B and C, if I'm looking at those, I can conclude is different. I cannot conclude is different. So really, I want to see this. Is 0 captured in my interval? And in this case, it is. That means there is no difference. I fail to reject the null. So if I fail to reject the null, I can conclude is different or I cannot conclude is different. Well, if I fail to reject, then I'm saying I do not have enough evidence to say they are different. So I cannot conclude they are different. So here how that would be going. I do not have enough evidence to say that they are different. That's the same way of saying I cannot conclude they are different. So C is the answer to question 7. Finally, a small reading one. I'm going to do the same thing I've been doing in this video, and I'm going to look at the answers for a second. I see they all look like they have the same setup for the mean, 0.03. I mean, one of them is negative, but they really all have the same mean, which means I'm going to go through, and since most of the answers have the same mean, I'm going to go start with the standard deviation. I'm going to focus on those parts because that's going to help me find out which to eliminate first. Because if I get one that's unique, there's my answer. If I get 0.047, then at least I can eliminate 3 of the choices right away. And so I'm going to use my standard deviation formula. And if I were to read the prompt, it says a simple random sample of 100, population A, 0.8 of successes, independent simple random sample of size 400 from population B, 0.5 of successes, and it does give me the order of subtraction, population A minus population B. That might be important later on. So if I'm saying the standard deviations where I'm going to focus, I'm going to use my standard deviation formula down there. And that standard deviation formula gives me 0.047. So I can cross out A, B, and E, which means C and D are left. So really, what's the difference between C and D? And that is the order of subtraction. It says find the difference in proportions, population A minus population B. Well, population A is 0.8. Population B is 0.5. So if I subtract those, I get 0.3, which means my answer is C. So my answer is C in this case because it matters what way I subtract them. But I started with the standard deviation first because the means were really similar to each other. The standard deviations were all, for the most part, different except for the 0.047s. So if I would have gotten, let's say, 1.3, there's my answer with less work. So learning how to read the choices and to help that determine where to focus on the work is going to help you as well. Let's move on to question 9. Question 9, how much more effective is exercise and drug treatment than drug treatment alone at reducing the rate of heart attacks among men age 65 and older? To find out, researchers perform a completely randomized experiment, Chapter 4, involving 1,000 healthy males in this age group. Half the subjects are assigned to receive a drug treatment only, while the other half are assigned to exercise regularly and to receive the drug treatment. The most appropriate inference method for answering the original research question is what? Well, I have population of 1,000 men, and I am splitting them and giving half of them one thing and half of the other, and I'm looking at, is one more effective than the other? That sounds like we're doing a 2-sample. So I know for sure it's either B, C, D, or E because I'm doing a 2-sample. Now I have to figure out, is it a 2-sample interval? Is it a 2-sample test? And that's where I'm going to focus first. Am I dealing with an interval or am I dealing with a test? And the prompt says in the top here, looking for a difference. You are looking for a difference. This means you are trying to estimate the difference. So that tells me right away I am dealing with an interval. So I can cross out a test. It's not asking me, and this is where it's a little bit hard, it's not asking me, is there a difference? You want to know how much more effective is it. So you are looking for a value. You're trying to estimate something. So that's going to be an interval. So now I have to figure out, is it a Z interval for P1 minus P2, or is it mean? So in other words, am I dealing with proportions, or am I dealing with means? That's really the difference between B and D. Well, in this case, how much more effective is it? So in other words, what percent? It's 20% more effective. It's 30% more effective. We're asking, look at this, how much more effective? And so I'm looking at a 2-sample Z interval for proportions. So that's question 9. Last one is question 10. And this one has some pretty deep stuff to it. Researchers are interested in evaluating the effect of natural product on reducing blood pressure. This will be done by comparing the mean reduction in blood pressure of treatment natural product group and a placebo group using a 2-sample t-test. It's giving us the information for the name. The researchers would like to be able to detect whether the natural product reduces blood pressure by at least 7 points more on average than the placebo group. If the groups of size 50 are used in the experiment, a 2-sample t-test using alpha of 0.01 significance level will have a power of 80% to detect a 7-point difference in mean blood pressure. If the researchers want to detect a 5-point difference, then the power of the test will be, well, I thought we only needed to know 1 minus beta for power. And, well, you're asked to find power, yes. But if you're asked to interpret power, no. You have to know the definitions. And so really, power, if you want to think about it, is the ability to reject a null when it should be rejected. So that's power. Rejected the null when it should be rejected. That's your value for power. You reject it, good job, it was supposed to be rejected. So I want you to keep that in mind. That's power, because this one's a hard one. If I go through and think about it visually, though, so here's what's going on. And if I look at it, that is an alpha of 0.01 off to the side, and that is red is where the rejection is. So if it falls in that region, and I reject it, and it should have fallen in that region, and I should have rejected it, power. That's really what you're looking at. And what I want to do is I want to show you the difference. So right now, there it is for the difference, and I want to show you what happens here. If I look at what happens next, if the difference is -7. So I'm going through, I put 0 in the middle, and I just kind of label what it's going to be, and it says 7, the power is 80%. So if the difference is 7, let's say -7, that power, 80% of it's going to be captured there. That's really what it's showing you is 80% of that distribution, it falls in the rejection area. So kind of look from here and up. As you see it's in the rejection area, all of it down here. That whole 80%, boom, 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 is where that alpha 0.01. So what happens if I want to change it? What if I want to make the difference now 5? And that's where I'm kind of coming through here. If I want to make the difference 5, so I kept the same information, notice in that case it's going to slide over more that way. And that's going to make it so I have a smaller area inside that curve. So now if I compare them together, you have the main one up here, you have the 7 difference here, and you have the 5 difference here. Notice as I start pushing this over here, it's going to get closer and closer and closer to that 0, which means that area down here becomes smaller and smaller and smaller compared to the 7. So really I want to compare this one to this one. And as I push in on that 5, and I know say I go to -4, -3, it's going to keep sliding to the right. And that means, in this case, I'm going to have less. So it is going to be less than 80% if I do that. Because that bottom one is going to go closer and closer. Now this one is a really hard one, but that is question 10. For the most part, I hope you could understand how some logic, some ways of eliminating choices is going to help you, or even sometimes starting with the answers to know what to read for in the prompt is going to make the problem go a lot faster.